Welcome, everyone. If you're just joining us for our final session, my name is Jake Rutka, and I want to thank you for attending Top Hat Summer Camp. Our final session is tackling an incredibly important challenge many educators are facing right now, and that's closing the achievement gap in STEM programs that keep too many students from realizing their dreams of becoming tomorrow's scientists, engineers, and healthcare professionals. Over the course of the coming 45 minutes, you'll hear from Justin Weinberg, who provide an overview of how Aktiv Learning's pioneering technology is helping students get a solid foundation early in the college experience to fuel their future success and master the most challenging introductory math and chemistry concepts. As always, I encourage you to use the chat to share ideas, resources, and best practices from your own experiences. And if you have any questions for Justin, please use the Q&A feature and we'll get as many of those answered as possible. Please take it away, Justin.
All right, thanks so much, Jake. Let me go ahead and share my screen. All right. Well, good afternoon, everyone. I really appreciate everyone here sharing part of their summer with us today and to learn more about how we can help you prepare to have a successful fall. As Jake mentioned, my name is Justin Weinberg, and I am Top Hat's VP of Product, and I am also the co-founder of Aktiv Learning, which we grew specifically to support and engage students in critical STEM disciplines. And as some of you may know, we were so proud and excited last December to officially join the Top Hat family, so our two teams could come together to transform STEM education at scale. And that's why I'm thrilled today to be presenting at summer camp to tell you more about how our team has been working to close the achievement gap specifically in math and chemistry courses. So just to give you a quick rundown of what we're going to cover today, we're going to spend a lot of time talking about the Aktiv platform. I do always like to start with the why. We'll spend a couple of minutes highlighting the readiness problem in higher education, specifically around STEM, and why we have such a need today to develop course-specific and STEM-specific solutions. We'll then get into the Aktiv platform, which I understand may be familiar to some of you in the audience today and brand new to many others who are here today. So we'll talk at a high level about what the platform is and some of its critical use cases. Once I give a quick overview of that, we'll then dive into our specific solutions for chemistry and math and how our team has developed technology from the ground up to tackle some of the most challenging topics that students face in these disciplines. Hopefully, we'll have piqued some of your interest today, and we'll share some information about how you can get access to the resources that I show today within Aktiv, and of course, leave time to answer any of your questions at the end. Now, while we are going to be covering a lot, we do want to be hearing from you. As Jake mentioned, we are going to be running both the chat and the Q&A during today's session. So if you have any discussions that you want to start with us, you want to hear what's on your mind, go ahead and just open up that chat and post anything for us there. If you have any specific questions about anything that we're covering today about Aktiv, please go ahead and just post those in the Q&A. What's really great today is that I have the help of my colleague, Blaine Alleluia, who runs the Aktiv support team. She's an expert in every single thing that we do, so she'll be able to interact with you and answer all of your questions. Now, we will have Q&A at the end, so if you want to hold your questions to the end there, please feel free to do so. If there's some questions that deserve discussion, we'll go ahead and hold those at the end, but please feel free to let us know what's on your mind. Now, before we get into Aktiv, we're going to talk a lot about that today. I did want to spend just a couple of minutes highlighting the readiness problem in STEM and why we have such a need to find new ways to engage our students in these critical disciplines. And for those of us who work in the classroom and work with students regularly in these disciplines, much of this is quite obvious today, but it's always good to look at some of the numbers around the problem. Some of you may be familiar with the ACT STEM score benchmark, which is a benchmark that basically outlines a 50% chance that a student graduating from high school today will earn a B or higher in a STEM-related course in college. In 2019, ACT released statistics showing that only 21% of students met that benchmark, and digging in deeper, only 2% of underserved students met that benchmark. And with the impacts of the pandemic on student readiness, which happened after these numbers were released, we know this isn't getting any better. Hopefully, some of you caught the unfortunate news released a few weeks ago that national math and reading scores have now plunged to their lowest levels in decades. And as we think about these students who will be approaching our college lecture halls in just a few years, we need to think about new ways we can make these students engaged and successful in our critical STEM courses. And that is exactly why we have developed the Aktiv platform that we're going to talk about today. So I want to start with just a quick high-level overview of what Aktiv is, what courses we cover, and what are some of the really amazing use cases that faculty take advantage of. Now, as the name suggests, the Aktiv platform is an active learning platform. Everything that we do is focused on how we can get students engaged, how we get students learning by doing, and how we can give them feedback so they can be successful in these critical disciplines. And as of today, we focus specifically on chemistry and math courses. So that's what we're going to focus on. Now, that all starts with our content library, which is a library of an extensive number, tens of thousands of problems and learning activities. Specifically for chemistry, we're talking about courses like general chemistry, intro and GOB courses, organic, and also biochemistry. For math, we're going to be specifically talking about courses ranging from developmental math through college algebra and pre-calculus, basically the algebra-based courses in the lower division level. Now, while we have tens of thousands of problems and we cover every single topic in those courses, that's not ultimately what makes Aktiv unique. What really makes Aktiv unique is the fact that we can go in and develop technology from the ground up that really helps students tackle some of the most challenging teaching and learning challenges that students face. So when we talk about chemistry and the courses that I just mentioned, we're going to be talking through examples around things like Lewis structures in Vesper, dimensional analysis, nomenclature, chemical equations, equilibrium, organic structure and drawing of curved arrows and mechanisms. When we talk about math, we'll be talking about some tools we've developed to get students to really show their work in reasoning and get feedback on that work. Again, around critical topics and skills like order of operations, solving basic equations, quadratics, systems, logs, and exponents. So a lot more to say there. But it doesn't just stop at the availability of content. It's also how that content is applied within your course. We built Aktiv as a platform to support learning both during class and outside of class. So that's why I'm really excited to next cover some of the amazing use cases that you as individual instructors can take advantage of. What's also amazing here is the flexibility that we've built into our platform. So I'll be walking through these main use cases. Do keep in mind that any of you can mix and match, just focus on one, anything that really helps you build that perfect course and to engage your students in the way that you desire. So the first use case I'll talk about, and we'll go a little bit deeper into this today, is how we can support you and your students during class. So this is the ability to take advantage of the devices that they bring to class every day, phones, tablets, and laptops, Chromebooks, anything like that, to get them engaged in problem solving. Now, I know many of you who work in the classroom all have different styles of how you work with students, how you achieve problem solving and achieve active learning. That's why we've made this use case flexible around you as well. So whether you're someone who likes to take attendance, poll, or do check-ins with your students, do live quizzes, replace or enhance traditional worksheets, facilitate group work, flip your classroom. These are all different ways that you can incorporate Aktiv to be successful in your course and get students engaged. So we'll talk more about that today. Another big use case for us is online homework and associated extra practice. So we frequently have faculty switch from traditional publisher online homework systems in chemistry. Those will be things like Mastering Chemistry, Connect, OWL, Sapling Achieve, things like that. In math, things like My Math Lab, Connect Math, WebAssign, and others that I'm sure you're familiar with. A big reason why faculty make that switch is because they really love the content in the system that I'm going to show today. The mobility, the ease of use, the feedback, the intelligent feedback that we'll talk about today. Instructors also tend to give us really amazing feedback on their experience in the platform in terms of how easy it is for them to set up their course, build assignments, pick their problems. Also, how it integrates into their learning management system on campus. So whether that is Blackboard, Moodle, D2L, anything like that, we can seamlessly integrate with those systems. So all the data and grades from Aktiv go into your gradebook there. We've also made a big push to make learning more personalized within the platform as well. One of the things we're going to be talking about today is a technology that we've built called adaptive follow-up. So what this is basically intelligence that allows us to really listen to where students struggle in the homework assignments that you generate for them. So as students go through the homework sets that you create every week or every other week, we can really see what learning objectives they're spending more time on, what they're spending more attempts on, where they're really submitting those wrong answers, and then curate automatically a spaced follow-up set so they get that extra support, sort of a spaced practice and repetition format, but really personalized to their level. So talking a little bit more about that. And then last but not least is the ability to do more summative assessments, the ability to deliver quizzes, the ability to deliver online exams. With this, we have a number of measures to help you maintain academic integrity and security. That includes things like integrated proctoring, so you can lock down your student's browser and monitor them. The ability to algorithmically generate problems and pool questions, so numbers get scrambled. You get different versions of the questions administered to your students, so they can't copy off each other as well. So whether you're someone who teaches an online course, whether you like to give weekly online quizzes, or if you just need to give online assessments for students who are sick or have reasons for that, you'll have that ability as well. So all of this is flexible, but just really wanted to outline some of those use cases. Now, what's also great is we're not just talking about this, we are actually doing this. We are working with faculty with this platform at over 700 colleges and universities across North America. This includes everything from community colleges, state programs, private four-year universities, and Ivy League schools as well. I did a quick scan of the attendees list here today, and I saw a good number of you who are part of our instructor community, which is really awesome, but also some fresh faces as well who are learning about the Aktiv platform for the first time. Now, as we get into specifics, the Aktiv platform supports two specific solutions. We have one for chemistry courses specifically, and one for math courses. So for those of you who are teaching chemistry courses in the realm of general chemistry, intro, GOB, biochemistry, we're going to be talking about the Aktiv Chemistry side of things today. For those of you teaching math, we have a separate Aktiv mathematics solution covering courses again from pre-algebra, elementary and intermediate algebra, college algebra, and then anything with trigonometry, which could include pre-calculus, whether that's separated or not. So we'll begin by talking about chemistry, and then we'll also talk about some of the amazing work we're doing on the math side as well. But one other point that I do want to make before we get into specifics is that while we do have these two separate solutions, we can take advantage of both of them together as well. So thinking about specific use cases for our chemistry instructors where math readiness may be an issue. So one of the big things that we've seen is students in chemistry struggling with basic math, which gets in their way of success. So if that is an issue that you are facing in your own chemistry courses, we can bring in some of these tools from the Aktiv math side to help you there as well. So just keep that in mind as we talk more. So as I mentioned, we'll get started by talking a little bit about the Aktiv chemistry side, and then we'll talk a little bit later about math. Now, while I could probably talk about each of these solutions for 2 hours independently, I don't have time for that today. So we're going to do some quick highlights from each one. And then again, we'll give you some information on how you can get access to the entire content library and the entire platform so that we can answer your questions and you can explore every single feature that we have to offer should you be interested. So starting on the chemistry side, one of the things I mentioned up front is that while we cover, all these different topics, thousands of topics in both our chemistry and math courses, we also really want to make sure that we are building technology from the ground up that really helps students address some of the most challenging teaching and learning areas that they face every semester and every year. So I'm sharing one of the first examples of that on our chemistry side, which is our bonding and structure module. So this is relevant for a lot of our first year chemistry courses where students are learning topics like Lewis structures, VSEPR, bonding angles, hybridization state, polarity, things like that. And again, one of the reasons why we built what you're seeing on the screen here is because students commonly struggle with these topics. But the other thing we've seen is that students really struggle with actually drawing structures online, because a lot of the online drawing tools out there today can be quite difficult for students to use and learn, especially when they're trying to grasp these topics for the first time. So for that reason, we built an entirely new drawing experience for students, which you're seeing here. As you can hopefully tell, this is very easy for students. Students just simply slide the dials on the left and the right of their screen. That allows them to control and manipulate properties like the number of bonds or number of lone electrons around a particular element as they're building it together. So again, just really makes that easy and intuitive for them to build whatever structure you ask them for. But at the same time, it also makes it very visual for them. A lot of students, as we know in chemistry, really struggle to visualize and see in 3 dimensions on their own. So in addition to making it easy to draw, we make that really visual with these nice animations that help them understand the relationship that exists between structure and shape. So while it's helping them draw, it's helping them build that intuition for the rest of the model as well. Now, on top of that, one of the amazing things that we've pioneered in Aktiv is a mobile-first approach. That means that every single thing that a student does in our platform, including structure drawing and everything else that I'm going to show you today, works exactly the same on their phone as it does on their tablet, on their laptop, on their Chromebook, on a desktop screen, literally any device that students want to use on any type of assignment that you give them. And we talked in the beginning of this talk about engagement. All right, and how critical that is, and how we need to be able to reach our students where they are today. On their phone is a great example of that. And because we build this in a mobile-first approach, we get to engage students when they're commuting, when they're on the go, when they're studying with friends on campus, when they have some downtime, waiting for class to start, or they're actually in class with you or in a recitation discussion section. All these opportunities we can now open up because of that mobility and the ability for students to access everything equally, no matter where they are. And the other thing that you're going to see as a theme today is feedback. When we built all of our content, we literally taught the computer chemistry to not only be able to grade student answers, but also give them feedback. So when students make mistakes in our platform, we don't just tell them that they're wrong and to try again, or just give them the answer. That intelligence is actually able to tell them why they're wrong, and not give them the answer, but help them understand that they have a wrong skeletal structure, that they have violated the octet rule on carbon, that they put too many valence electrons in the structure, that they didn't minimize formal charges when they were supposed to do that within the question. This keeps the students engaged so that they can understand where they're going wrong. They don't feel lost. They don't feel the need to just try to go look up the answer from somewhere else. This has been critical to success in a lot of our courses. So again, those are the main themes that we want to really be building into our content and our problems, which you'll see today we repeat: that mobility, the ease of use, the scaffolding, the visualization, and the intelligent feedback. And we just continue to promote that through other critical areas, right? So nomenclature in chemistry is another one. Unfortunately, a lot of students struggle with nomenclature because they don't practice, or they don't practice enough. So we really wanted to create an environment that encouraged students to practice. So we invented a technique called smart suggestions, which is what you're seeing here on the left side of the screen. With smart suggestions and nomenclature, we give students these different randomized chemical components, things like prefixes, suffixes, stems of elements, Roman numerals. And so the students are essentially building their names for these different components. But hopefully, as many of you see, many of these components are wrong. We purposely give students a lot of wrong answers here, a lot of wrong options. So they really have to think about the process of naming, whether something is ionic or covalent, whether they are mapping the element symbols to the names correctly, whether they're dealing with transition metal ions, whether they may or may not be present within the compound. This gives students the opportunity to make mistakes as they're learning, but also creates that environment where it's just so easy to try something, do something, make a mistake, do it on their phone, try again, right? And as they do this, they get that intelligent feedback that is present within every problem. So inevitably, when someone puts in titanium dioxide as the IUPAC name for TiO2, again, it doesn't just say, you're wrong, try again, but it actually tells them things like prefixes are necessary in ionic compounds. Or if they put tin instead of titanium, another common mistake for beginning students, it'll tell them they have the wrong names for their element symbols and to go check the periodic table. Because that's worked so well, we have brought smart suggestions into all the problems that also involve writing a chemical formula or a reaction or a chemical equation. This is present in many different topics throughout first-year chemistry, where students have to go from name to formula. They have to predict products of precipitation reactions. They need to balance equations. They need to come up with electron configurations all the way through redox reactions in the second half of general chemistry. And what we've heard from a lot of students is that when they're traditionally faced with these types of questions, they really struggle with formatting, especially the ability to enter basic things like subscripts and superscripts in chemistry. So that's why we also extended the smart suggestion format to easily have students put in a subscript 6 or whatever subscript they need, or a positive 2 charge or state of matter, again, so they can focus more on what they're doing in the chemistry, learning and getting feedback, rather than kind of fighting with the technology and dealing with formatting. We've also put a big focus on quantitative topics. Dimensional analysis is one of my personal favorites because it's so fundamental to student success in first-year courses like general chemistry, intro, and GOB. What we've built for students in dimensional analysis is an interface that requires them and really encourages them to show their work and really understand and repeat the process that we try to instill with them when they learn dimensional analysis. And for those of us who teach chemistry, we know this is not just a skill for unit conversions, it's for moles, it's for stoichiometry, it's for density problems, it's for solution concentrations, it's for thermochemistry. So many areas where the skill kind of lays the foundation for success, as I mentioned. So what we've built here is essentially like virtual training wheels for students. It's an opportunity for them to show their work, get some color coding and visual feedback so they can distinguish between values and units when they approach the process of dimensional analysis, and really get a sense of how they're supposed to kind of problem solve. I use the analogy of virtual training wheels for a very specific reason, which you'll see in a second, but it's sort of that beginning phase that we want to take students through to make sure that they understand the process, they get that foundation, they get engaged, and they get feedback as well. So as hopefully you noticed, just like the smart suggestions that I showed earlier, we do give the students the opportunity to make mistakes. So that includes not only mistakes in the answer, but mistakes in their work and their setup as well. And because our feedback is intelligent, we give the student the ability to get feedback not just on their answer, but also on their setup. So when they make a mistake, we're not just going to tell them your answer is wrong. We're going to tell them you've arrived at the wrong answer because you've inverted your first conversion factor here, or you haven't included the right molar mass for the compound that you're working with, or you have the wrong ratio between grams and milligrams in this conversion factor that you're working with. We can also distinguish between a setup error and a calculation error, which can be quite common for students as well, unfortunately. So if a student does set it up right, but has the final answer wrong, we can narrow that down to maybe they hit divide instead of multiply in their calculator and really highlight that and bring that to the forefront for students. So that's sort of that foundational phase. But in addition to that, we want to take the training wheels off. So while we give the students in chemistry that foundation to show their work and reasoning, get that feedback, we then remove the scaffolding and present students with the same types of questions or more challenging questions in a numeric entry format so that they can experience questions that are going to be more like their assessment, where it's just going to be them, maybe a sheet of paper or a pen or a pencil on the side, and their ability to kind of work up the reasoning to arrive at the answer. We'll give them feedback, of course, at the end, but it does sort of, again, take those training wheels off and give the students the ability to kind of get ready for the assessment. One final example I want to share with you all in chemistry, which is another one of my favorites, deals with organic and biochemistry, and this is the Aktiv grid. This is our drawing system specifically built for organic as well as intro biochemistry that enables students to intuitively draw organic skeletal structures and structural formulas, as well as intuitively draw curved arrows, again, dealing with reaction mechanisms there for those of you teaching in those specific courses. So this is really supporting anything from basic nomenclature exercises, synthesis, spectroscopy, reaction mechanisms and resonance. And then we also have some special exercises around chair, Newman projections, as well as Fisher projections for those of you who want to learn more there as well. So those were a few things that I wanted to share specifically on the chemistry side. Want to spend a little bit of time now talking about some of the amazing work our team has done in math. Now, while again, we can talk probably for an hour or two about all the work that we've done in math, do only have time to share some of this specific examples that we're particularly excited about today. And again, for those of you who are in math courses and want to learn more, we can give you some information on how to get access. I believe my colleague Blaine has actually posted a link in the chat, and we'll post that again a little bit later to make sure that you all have that info as well. So one thing that I want to particularly start with in math is something we call scaffolded mode. A lot of what we've done in math is actually inspired by a lot of the work I just showed you in chemistry, where we've been able to see a lot of student success and a lot of benefit by providing student scaffolding. But specifically in math, we really wanted to create an environment, as we've heard from instructors, to have students show their work in reasoning and to be able to get feedback on that work, just like I showed within dimensional analysis. We also wanted to create an environment that would lower the barrier to math and really cater to the students who unfortunately enter our math courses with anxiety, a preconceived fear of math, that they can't do it or math isn't for them. So a lot of what I'm about to show is specifically addressed towards those types of students. With scaffolded mode, we have created an environment where students can literally interact with the math on the screen. So we can look at this for a number of topics, but let's start with something pretty simple, just to kind of get the idea. Let's say we ask the student to solve a basic linear equation, 2x plus 3 minus 1 equals 8. With scaffolded mode, students can literally interact with the math on the screen. Just by tapping or clicking, they can interact with the equation, they can interact with the left-hand side or the right-hand side, or they can interact with actual individual terms of the equation or expression given to them. For example, the student can narrow down to that individual -1 if they'd like. Now, once they have those terms selected, they can interact and manipulate with them. So just by dragging and dropping terms on each other, like that -1 onto the +3 to the left of it, the student can give us an intention that they want to combine like terms. So because they give us that intention, what we do is we pop up this little contextual menu, which essentially assesses the student's ability and understanding of that particular operation that they're trying to perform. Now, this is basic order of operations and combining like terms. We know the answer to this is +2. But as you can see, we algorithmically generate different distractor options. So if the student happens to be behind on some basic arithmetic or order of operations, we give them the opportunity to make mistakes. This also extends into other manipulations like adding or subtracting from both sides. So just by dragging the resulting +2 from the left-hand side to the right-hand side of the equation, we understand that that's an intention that the student wants to add or subtract that 2 from both sides. So as you can see here, we ask the student to understand, what's going to happen to that 2. Does the sign change? Does it remain a +2? Giving them the ability to make that mistake and show us that intention. Ultimately, students get to repeat and go through a number of steps in this interface. And that's why we also give them the ability to see their work as they're doing this. So just by pulling down right on the screen, the students can see a whole series of steps in terms of how they've started the problem to where they've arrived at for that particular exercise that they're working on. And ultimately, when they feel that they've arrived at the correct answer, they can submit that for grading. When we grade the student, we not only, again, tell them if they're right or wrong, but why. And here we're able to go a step further by outlining all the steps that the students taken in this nice timeline, numbering them, and then pointing out specifically on which step they've made that mistake. So in this case, the student's working on an order of operations problem, and we can point out on step 2 that it looks like they've incorrectly combined -3 and a -7 in that step, and to make sure to pay attention to the double negative when trying again. The student, unfortunately, here chose +10 instead of +4, which it should have been. And when they then retry the problem, which we'll give them the opportunity to do, we don't just take them back to where they left off. We actually take them back to the step where they've made that error so that they can actually try that step again, hopefully choose +4 instead of +10 this time, and then go from there. So that's a little bit of kind of the philosophy behind scaffolded mode. But it's not just about order of operations and solving linear equations. It's really about targeting some of the most foundational areas in math that we really see gets in the way of student success. So I showed one example around order of operations, but we can also extend scaffolded mode into concepts like rational expressions and fractions, which is something that students struggle with. So with a rational expression or a fraction, students can manipulate things like leading negatives. Unfortunately, this is an area where students have a lot of common misconceptions, where they may pull out a leading negative in front of a fraction before actually factoring out that -1 to begin with. so we can capture that intention and capture the student reasoning there. Speaking of factoring, we also enable students to do that within our platform as well. So by selecting an expression or part of an expression, for example, maybe the denominator here, 4 plus 2x, the student can choose from a series of actions, for example, factoring. But once they choose factoring, we'll ask them what they want to factor by. Let's say they want to factor by 2. We then assess their understanding of what that resulting operation would be, what it would look like to then factor out 2 from that denominator. We also have extended this into exponents and logarithms. When a student interacts with an expression or a term with an exponent, it automatically enlarges so the students can individually interact with that exponent. They can then drag it to the base, and then we take them through a series of questions to make sure that they actually understand the rules, whether they're adding exponents or dividing exponents or multiplying exponents. Again, these are common misconceptions that students have that we can capture their step-by-step thinking. We have this for quadratic equations. So here the student will be asked to identify the right form of the quadratic equation and then individually connect the coefficients in their quadratic equation to the quadratic formula, making sure that they actually set that up correctly and then have them actually work through the solution. One of the cool things you'll see here is actually once they kind of operate across the plus minus, which you'll again see once this repeats, we do break apart the two solutions to help the student understand where the two solutions come from for that particular quadratic equation. So you'll see that right here. One last example I wanted to show today in scaffolded mode was systems of equations. So again, system solving by elimination or substitution. I believe this one is an example of solving by substitution. And what's really great about this is not only the visual manipulation of the terms in each individual equation, but the ability to make substitution tactile. So as you all hopefully saw there, we can actually have a student take that first equation for y and visually substitute that into the second equation so they can actually understand that concept. And then again, substitute the solution for x back into the first equation to arrive at the system. So that's scaffolded mode. Hopefully everyone kind of understands the idea there in terms of how we tackle those foundational concepts. And then what I also want to highlight today is stepwise mode. In stepwise mode, we are beginning to remove part of that scaffolding that we just showed within scaffolded mode, but still support the ability to have students show work and reasoning within that as well. For those of you familiar with some of the recent developments around like AI and ChatGPT, you can sort of think of stepwise kind of like a ChatGPT, but specifically for math and specifically to kind of help students learn and show their reasoning. We actually specifically crafted the stepwise interface to kind of work like a chat function. So it's almost like the students are having a conversation with the platform. As the name suggests, stepwise enables students not just enter answers, but actually enter steps of work. So when a student is given a problem, they can actually enter, what they believe their first step is, and we actually have AI check if that step is along any relevant mathematical pathway. So if the student comes up with a step, we can see, is that an appropriate step towards the solution or is it not? And if it's not, we can actually give them feedback as to why. What I really do want to emphasize here is that we're not prescribing steps. We are allowing students to show any of their relevant mathematical reasoning here, whether that's correct or incorrect, but really want to give the students the freedom to kind of think that way, not prescribe them steps. Now, once they do make a mistake on a step, we do give them the ability to try again and get back on track. They can easily copy any step that they work on, change an X variable to Y variable, vice versa, and you can see how they can put themselves right back on track. This will, of course, continue until they arrive at the full solution, which will then alert them and kind of give them confidence that they've arrived at that final answer. So hopefully this gives you all a sense of some of the amazing work that our team has been doing to close the achievement gap in both chemistry and math. And what I wanted to wrap up today doing is sharing some of the amazing use cases that our faculty are taking advantage of to apply this content both during class and outside of class. Hopefully, as I went through the examples over the past 20 minutes or so, many of you can imagine sort of having your students maybe work on those exercises on their own time so they can do homework and they can do practice and they can sort of prepare themselves for a quiz or exam. And that's a wonderful use case. But what a lot of our faculty do is take advantage of this during their lectures and during their class meetings as well. To maybe help visualize what that looks like, what our instructors will do is easily push out activities so students get any of the problems we talked about directly on their personal devices, whether that's their phones, tablets, laptops, Chromebooks, anything that they're bringing to class every day. We usually see a mixture, but phones tend to be quite popular. And any of the content applies. So in this example, I'm going to show an example of faculty assigning a Lewis structures drawing question, which is an amazing example in first-year chemistry to get students engaged. But this could be dimensional analysis. It could be scaffolded mode or stepwise mode in math, anything that we showed off today or anything in our library. The students get the opportunity to work on those activities during class and also get all the amazing feedback that we discussed. So not only do they get to submit their answer, but also get the opportunity to understand at a personal level how they're doing. Are they on the right track or the wrong track? And that stays with them as well. So they have the ability to review that after class should they so desire. What's also great for our instructors is that we give you real-time analytics during this process as well. So not only are your students getting that experience, but we also give you the ability to see not only how many students are getting the problem right, but what the actual 3 common mistakes are. When we talk about structure drawing, we are actually showing you the actual structures that your students are submitting, not what we've anticipated, but what your students are actually coming up with. It's like being able to see what your class is drawing in real time, or what compounds they're naming, what chemical equations they're coming up with, what mathematical expressions they're ending up with at the end of a particular math exercise. Again, any of the content that we showed today can apply to this, but this is a particular example. I just wanted to help to kind of visualize what that process would look like. Another thing that we have developed, which we're talking about a little bit about before, is something called adaptive follow-up, which works on top of our homework assignments. So while we want our students to be successful in our courses and learn the concepts, we also want them to have long-term retention of those concepts as well. It's not just enough for them to kind of learn that for a day and then forget it. We want them to really sort of have those concepts ingrained. And that's why we've done a lot of work to promote spaced practice and repetition within the Aktiv platform. Some of you may be familiar with the curve of forgetting, which is probably intuitive to us as educators, but there's a lot of learning science around this as well. The basic idea is that if you learn something for one time, over time, whether it's weeks or days or months, you're ultimately going to forget some of it or all of it. But if you repeatedly come back to that, particularly in areas that you're struggling, and repeat that learning and practice, you are going to generate longer-term retention of concepts and ideas. And this is learning science has been studied by literally thousands of scholars in all disciplines. So it's pretty cut and dry in terms of how this benefits students. We have implemented this in practice with our adaptive follow-up technology. It's a pretty simple idea. As students work through homework assignments, whether that's a chemistry assignment or a math assignment that we talked about, inevitably some of them are going to struggle in certain concepts more than others. Some of them are going to do great, some of them are going to do okay, some of them are going to struggle. And some of them, depending on their preparedness level and where they're coming from entering your course, are going to be kind of in different parts of the map. This is going to happen in every course. But what we can do is really listen to where students are in terms of what particular learning objectives they're struggling with, and then automatically curate an activity for them that helps them brush up on those concepts. But again, we want to do this in that spaced practice format. So a few days later, after they've submitted their homework assignment, after it's due, we're able to come back to the students and really make sure that they are getting that extra support that they need. So they get a notification from Aktiv saying that a follow-up has become available for that particular homework set, and then they can go in and practice more. We also give instructors the flexibility to make these follow-ups required or optional. We have instructors who kind of live in both camps. So some will kind of make this as sort of a required part of their homework sets to kind of complete the follow-up. Some will make that optional extra practice as well. So I want to make sure we could cover that as well. So we're approaching 2:40 here on the East Coast. So I do want to maybe just wrap up a little bit with pricing, because I know that was a question that came up in the chat and the Q&A. So I just want to quickly cover that, and then we'll give information on how you can get access, and then we'll close for Q&A at the end. So one of the things that's really important to Aktiv and Top Ed together as a mission is to create an environment and a product and a platform that is affordable for students in all of our courses. And that's why we have priced our platform at $42 for students' first semester and $33 for any additional term after that. We also have similar pricing for schools on the quarter calendar, which you can see here. But basically, this is dynamic pricing, where students' first semester is always at $42, and any subsequent term after that, whether that's the same course or a course that follows in their second year, will be priced at $33. So there's an advantage to students, an economic advantage if they continue on with us. This includes everything in the platform that we've talked about today, including proctoring. We have integrations with OpenStax as well, which you didn't have time to talk about. And we also have a number of flexible options in terms of how this is implemented in your course. We have grace periods. Students can go through the bookstore. We have inclusive access setups, department pay, anything that your students need in terms of setup or purchasing method, we can work with you. The other thing I do want to mention is that all of our courses are lifetime access, meaning that students retain access to all the material in their course and their assignments so they can practice even after the course is over. We have a lot of STEM students who are pre-meds. So as they take chemistry and math courses, they'll be able to review that content even after the course is over at no extra charge. So that's something that we kind of put the extra mile on, make sure students are getting a lot of value out of what they're purchasing for their course. So with that, I am going to ask my colleague Blaine to post this special link that we have for you. You will be able to click this link and sign up for a time to get access to our platform, whether you're a chemistry instructor or a math instructor, or just someone who is interested in getting access to the platform for your colleagues or for whatever reason, your department. Blaine, if you could please post that in the chat, you can just click that link and we will help you out. We'll pull that up again if you need it, and we'll also send that as a post-webinar email. But at this point, I do want to make sure that we leave some time for questions. So I am going to look through the Q&A here. If anyone wants to post any questions in that Q&A that you've been holding, please feel free to go ahead and do that. And I really want to just thank you for attending today and sharing your time at summer camp. All right, so there was one question in the Q&A about are there plans to extend Aktiv to physics and physical chemistry? So I don't have any specific plans to share on that today, but for those of you who have been watching us over the years, you've sort of seen us expand from one chemistry course to many and to other disciplines. So I would say that inevitably over time, we will be expanding our course coverage and our disciplines, but I don't have any specific timelines to share there, but I appreciate the question. There was another question about what is the learning curve for the software for scaffolded mode for teachers, for students. So we have had the fortune of implementing scaffolded mode now in many courses. We're seeing a pretty minimal learning curve. We do see that students find it to be fairly intuitive. We do also make training activities available for all of our interactives. So if you want your students to kind of go through an exercise of learning how to use scaffolded mode, we do have that as well as stepwise or any of the other chemistry interactives that we showed off today. So thanks for that question. All right. Any other questions that we want to go through today? Maybe Blaine, you can post that link one more time for those interested. We got one more question that I'll answer. Is integration and differentiation available in scaffolded mode? So Namdar, unfortunately, we are only supporting pre-algebra through pre-calculus with our math solution at this time. So we don't have calculus support yet. So I'm sure we'll eventually get there, but those would definitely be some some critical areas should we build scaffolding mode for calculus. Blaine did let me know that there was a question about if students are charged for math and chemistry separately. That's sort of a nuanced question that might be better answered sort of maybe on a discussion. So if you want to sign up for some time and we can kind of figure that out with you. So I'm not sure if that's a chemistry instructor asking about math support or whether that's separate math and chemistry courses. It really depends on the setup. So, if you are interested in sort of both solutions for different needs, please sign up for a time with us and we'll be able to kind of figure out what the appropriate answer is. All right, so at this point, I am going to hand it back to Jake to close us out.
Thank you, Justin. And yes, while I do close it out, you'll see a poll has popped up on your screen. So please do take some time to answer that. Thank you to Justin. Thank you to all our presenters from today. And to all of you out there, whether you joined us for a couple of sessions or stuck with us throughout our summer camp programming, I wanted to say a big thank you for spending your time with us. We hope you picked up some new ideas and a little inspiration for a great fall semester. In the coming days, we're going to be sending out a few emails to you that'll have the webinar recordings, presentation slides, and links to helpful resources that'll help set you up for success. And of course, you can always connect with your Top Hat account rep for a refresher. And if you don't know who that is, send an email to support@tophat.com and we'll get you connected. Right. Okay. And we've got lots more to offer to help you hone your teaching practice, starting with Top Hat Engage in San Diego, California on October 26th and 27th. This is our marquee conference featuring inspiring keynotes, peer-led workshops, great food, cocktails, and plenty of time for networking. This is truly a wonderful, intimate conference, and we get nothing but great feedback from our attendees. And while we're still in planning process, our Higher Learnings webinar series will be making a comeback this fall. For those who haven't taken part before, these webinars feature some of the leading thinkers and change makers in higher education, like James Lang, Pooja Agarwal, and our summer camp keynote, Jose Antonio Bowen. We'll make sure to let you know when these are coming back, so look for communications from us in the coming months. With that, I want to thank you again for attending summer camp. From all of us at Top Hat, we wish you a great fall semester. So long.